My name's Moffatt. I'm a developer advocate at a company called Confluent. Confluent's one of the companies behind the open source Apache Kafka project. I'm based in the north of England in a town called Ilkley, and I'm going to talk all about Apache Kafka. I'm going to explain what it is and what it isn't. It's not just a messaging queue, it's not just a pipeline to get data from one place to another, it's an event streaming platform. So come and join my talk and learn all about that. Good morning, good afternoon, welcome to this talk. My name is Moffatt, I'm a developer advocate at Confluent. And I want to spend this session telling you all about Apache Kafka and the wonderful ecosystem that exists around it. If you want to, you can follow me on Twitter, I'm @armoff, you can see the handle on the screen there. So let's start off with talking about why we even want to be thinking about something like Kafka. And at the very heart of Apache Kafka are events. And events are these fantastically powerful things because they exist all around us. If we think about the data we work with day to day, a lot of it starts life as an event. But what actually is an event? Well, events have these fantastic properties, these two properties. They tell us that something happened, and they tell us what happened. And events occur continually over time, unbounded series of events. Now, events can be human-generated, they can be machine-generated. But as I said, most data that we work with day to day in all of our systems starts life as an event. So let's think of some examples of different events. We've got human-generated ones. We've got a human walks into a shop, or nowadays probably clicks on a website, and they buy something. You have an event. Something happened, a purchase was made. What happened? They bought a camera. When did it happen? It happened at this particular time. Or we moved some stock in a warehouse. What happened? Stock movement. Or sorry, something happened, stock movement. What happened? The stock was moved from this location to this location at this particular time. These are events. We may capture them later on in like a database or a NoSQL store or something like that, but it started life as an event, an unbounded series of events. These things are happening continually. And we have machine-generated events. We have network devices and routers and firewalls saying like, we had this many packets, or there was an attempt on this particular port. We have IoT devices sending out readings and light readings and temperature readings and all these kind of things. The applications that we write emit events. Something goes wrong in the application and it writes out an error. That is an event. Something happened, there was an error. What happened? Here is my stack trace. So all of the data, almost all of the data that we work with day to day starts life as events. And events are very, very powerful. They're all around us, and they let us do very, very powerful things. They let us build systems that respond to something happening in our business. Instead of writing that thing into a database and then our application going to check, has something changed? We can actually say, when something happens in our business, we're going to respond to that. And that lets us build nice responsive applications for our users. We can use events to drive our analytics that people can look at information as it happens and not as it was yesterday. So we can build these systems using events as a first-class object, not as like an afterthought bolted onto something else that wasn't really designed around events, but you can actually build on a system powered by events. So how are we going to do that? Well, the title of the talk gave it away, but let's think about how we actually get there. So here's an event, our humble little event. But events don't happen in isolation. We have many of them. Events can happen at a rate of 1,000 a second or maybe like 2 a day. They're still events. There's nothing kind of inbuilt into how often they have to happen, but they happen and they are unbounded. So we have these events happening. And within these events, let's start to think about how we're going to capture that data. We're going to simply say at this point, we have a key and a value. And that's going to hold all of the information we have about that event, or pretty much all of it. Where are we going to store it? We're going to store it in a log file. So this is what sits at the very heart of Apache Kafka. It's a distributed, immutable, append-only commit log, which sounds fancy. What's that actually mean? Well, imagine you've got this log, and we're going to capture our events in it. So as something happens, we write it to the log. And something else happens and we write it to the log. And so over time, as these events are occurring, we're appending them to the log. We're appending them, which it means that we can't go back and change things. It is immutable. So as something happens, as we place an order, as we place another order, as we change an order, Those are all events that go to the end of the log. Now, this is great because we can replay those events to find out what happened over time. We can replay those events to rebuild state. So we can say we've got a particular order, we've got a bunch of different events to do with that order. What's the current state of that order? And here are all the different stages that it went through, because we're capturing all of those different events. But it is immutable. We can't go back and change things. We may be having an event that kind of models a conversation between two people, and maybe they have an argument or they disagree about something. Well, if you say something in the heat of an argument that you probably wish you hadn't, you can't go back and unsay that thing. It has been said, and these events are immutable. Once the event is written to the log, you cannot change it. You can kind of do the human equivalent of kind of like saying sorry and trying to undo it and send another event to that log, which counteracts the previous one. But once events are on the log, they're immutable, which is a fantastic property to have because you can build some systems around that relying on that property. So we have these events on the log, and within the log, we can see that we have this model of what happened over time. So events give us this ability to model our businesses. We can say what's happening in our business, and orders are in place, and stock is being moved, and sensors are being read. These things are happening continually over time, and we can capture those within the log. But the log is a bit of an abstract concept, and it does actually exist on disk. If you can like dig down into the thing, you can actually go and see here is the log. But we want something kind of more useful to actually work with, rather than just like one great big log of lots of different types of events. So in terms of types of events, let's carve those up. Let's give them somewhere to live within that log. So we're going to say, well, let's take that log and we're going to split it conceptually into what we're going to call topics. So we can have a topic that describes clicks on our website, that describes orders being placed. We can also have topics which describe what we might know as reference information or lookup information. So whilst clicks and orders are like nice and easy kind of concepts to think of, like these things happen over time and orders are always being placed and clicks are always happening on our websites, customers isn't immediately obvious why that's an event, because a customer is a customer, they're not an event. Well, customer entity is, because you have inserts, you have creates, you have updates, and sometimes you have deletes. And each of those is an event. So when we create a customer on our system, that's a create event. We store that on the topic. And then the customer moves house, that's another event, it's an update event, and we capture that on the topic. So now on that customer topic, we have all of the information about that customer, so we can rebuild the state, so we know where that customer currently lives. But we also have an audit of what are the stages that customer has been through. How often have they moved house in the last 2 years? How long have they been a customer? And we have that from all of the events we've captured on the topic. Now, Kafka gives us the foundations on which to build our applications. So with this raw data, any of the things you can think of that you want to do with the data, you can. But the point is we're capturing it, we're modeling it as a series of events to start with, and then we do the other things with it, because Kafka gives us that foundation. Within these topics, we're going to carve up that data one more time. We're going to say, well, we've got information about clicks on our website, we've got loads of clicks coming in. Well, we're going to take that data and we're going to partition it. Because I mentioned briefly earlier, Kafka is a distributed system. So we need a way to be able to like scale out this data and also scale out the processing that we're going to do on it. So we're going to take a particular topic, like our clicks, and we're going to partition it. We're going to say we're going to have one or more partitions. Now, you can have just one partition if you want to. That's not usually what you'd end up doing. So you'd have maybe 2 partitions or 6 or 24 or how many partitions you want. We'll talk in just a moment about how that data gets arranged across those partitions. But we have a topic, we partition it, and now here's our second fantastic guarantee that Kafka gives us. As well as the immutability of the data once it's been written to Kafka, we also have the guarantee that within a partition on a particular topic, the data is strictly ordered. So the order in which the data gets written to the topic, into the particular partition, is exactly the order, and this is guaranteed, the order that you'll read the data out of that partition. So again, if we were thinking about customers, for example, we're not going to see this customer moved house before we actually know, well, that customer has been created, because that would be silly. Or here is an order update, or this order is shipped, but we've not actually received the event that says the order has been created or fulfilled yet. So the strict ordering of events on partitions is super important. So just make a little mental note about this idea of partitions, because we're going to talk about it in just a moment. And we talk about getting data in and out of Kafka. So let's do that. Let's talk about getting data in and out, or publish and subscribe. Now, I forgot to mention earlier on, Kafka is fairly well known in some circles. You may have heard of it before today, you may not. That's absolutely fine. Like, people have lots of different experiences in the tech world. And some people have heard of Kafka, and some people mentally bracket it in like, oh, it's a message queue. Or like, oh yeah, Kafka, it's a pipe for getting data between like these two different points. So when I say pub/sub, Kafka is not just pub/sub. In the same way that Kafka is not just a message queue, it's not just a pipe. Kafka is an event streaming platform. I'll talk about why on earth it is that in a moment. But just to kind of like make that little flag there, Kafka is not just these things, but it does do pub/sub. So if you're familiar with the concept of pub/sub, of publishing data and subscribing data, we can do that with Kafka, and let's see how. For publishing data onto Kafka, we're going to use something called the Producer API. And the Producer API does exactly what we talked about earlier. It appends events to the end of the log. So we say something has happened in our application that we want to write to Kafka. We use the Producer API, and the Producer API is responsible for getting that data to Kafka. You say, here is my key and value, here is a topic, here is the broker, off you go. And it says, right, I'm going to write the data to different partitions. And there's a bunch of different client libraries. So here's an example using the Go producer. So you take your message, you say, here is my producer. Excuse me, we're going to create the producer. We're going to send the data to this particular topic. And the producer will work out which partition that data needs to go to. So this is where the key comes in. So I said earlier, events, we're going to model them as key value. Now, value could be a single byte. A value could be a hugely complex payload. Like usually with Kafka, you'd probably stop at about a megabyte or so by default. You can do more if you want, but like a megabyte is thereabouts where you'd have to start reconfiguring things a little bit. But you can put whatever you want into the value. You can put whatever you want into the key, but the key determines by default where your data is going to reside on partitions. So if there's no key, then the data just round robins across all of those partitions. So you get a nice even distribution of data, but you don't get any business logic in terms of where that data resides. We're going to talk in just a moment about reading data off of Kafka, and this is where it really matters which partition data resides in, depending on the application you're building. Sometimes it doesn't. Sometimes it's just like, throw the data in, keys don't matter, we just want a nice even distribution. A lot of the time, though, you do. Because the key, if you set it, will determine which partition the data is going to get written to. It'll take a hash of the key. And this is important because if you think I'm going to partition my data based on order ID, because we want to make sure all of the data for a particular order ends up in a particular partition, you say, well, I might have 1 million orders, so I need 1 million partitions. That's not the case. You could have 2 partitions. And if you have 1 million orders, you'll have 500,000 orders on one partition, 500,000 orders on the other partition. It just takes a hash of the key. But because it does that, it means that all 500,000 orders for the same orders will exist on one partition and the same on the other. So you get a nice even split, but the same events for each order always reside on the same partition. And probably you might scale out further. You can have 4 partitions or 10 or however many you want to. But it takes a hash of that key. So the Producer API is relatively simple. We use it in our client applications. There's a huge number of libraries available. It puts messages onto topics. It handles all the nitty-gritty of like the network protocol and partitioning and stuff like that. And there's also a REST proxy available if you want to use that. So by default, you'd usually use a client library because you're going to get better performance. But if for like network reasons or your client library your language that you're using doesn't have a native library, then you can use a REST proxy. Now, how do we get data off? This is the sub part of pub/sub. To get data out of Kafka, the consumer API goes to a particular topic and it reads data from that particular topic, from the log that we've got. Now, access is sequential. So a consumer comes along and said, I would like to read data from this particular point in the log, and I'm just going to scan through there. We don't do kind of like random access and like this one here, that one there, this one there. You could, but you're responsible as a consumer for kind of like doing that seeking around. So consumers read the data and consumers have their own position within the log. Now, this is a really important difference between Kafka and other systems you may be kind of like mentally bracketing it with. Because data in Kafka does not get deleted once a consumer has read it. Data in Kafka gets deleted based on separate stuff. Like you define a retention policy for different topics, that defines when data gets deleted. When a consumer reads data from a topic in Kafka, all that happens is optionally and by default, Kafka says, okay, this consumer has read that message. So next time they connect, I'll kind of like take them to the next offset in the log. So we have offsets in the log. We have like the earliest offset, which is at the beginning of the topic. We have the latest offset, which is at the end of the topic, the new messages as they arrive. And we have all the offsets in between. So consumers can say, like, I'm a different consumer. So Sally is our first consumer. She's reading messages at the head of the log as they arrive. Fred comes along and says, I'm a completely separate application. Sally's doing fraud processing. I'm doing inventory management. Fred says, I would like to go back to the log as it was at 2 o'clock yesterday afternoon. And it will scan to that particular offset in the log, and it can read all of the messages through from there. Another application comes along and says, oh, I'm doing analytics. So I'm going to connect, I'm going to read all of the messages from the beginning of that topic to populate my data store over here. And it's going to suck all of those messages out of the topic and put them over here. The point is we can build separate independent applications using the same data that are not coupled together, and that when one reads a message, the others, it doesn't get deleted, the others can still read it, and we're not having to declare our subscribers up front. So consumers, again, this is an example in Go. In Go, you can like consume the messages off a channel if you want to. You simply say, here is my topic. I would like to read the messages from here. By default, it's going to go to the beginning or the end of the topic, depending on what you set, and you just receive those messages as they arrive. So here's our first application. If we've got 4 partitions, the application is going to get data from all 4 partitions. Wouldn't be much use otherwise, because otherwise your application wouldn't get all of the data. A second application comes along. It also gets all the data from all 4 partitions, because you have 2 logically separate applications doing different things that need to consume all of the data that's happening on that topic. Now, application 1 here, perhaps it needs to get a higher throughput of its processing on that data. Application 1, it sits on a single instance, and like we've scaled the box up and given it lots of CPUs, and it's reading the data as fast as it can from the topic, but it's doing some fairly complex stuff, and for whatever reason, it can't keep up with its processing. So Kafka's like, here's your data. The application is like, whoa, steady on, I can't keep up. So we can say, well, let's scale our application. Let's actually add in additional instances of that application. Now, Kafka's great here. Kafka says, okay, that's great. We've still got 2 logic applications, but our first application, it's got additional instances. So I'm going to form what's called a consumer group. And within that consumer group, I'm going to allocate data or partitions to the individual consumers within that group. So if you have 4 partitions and 4 consumers, each consumer in that group gets data from one particular partition. And this, you'll be able to see, is why the data going to different partitions is important. Because if one consumer here is processing particular orders, it's going to expect to get all of the events for a particular order. So if C1 is processing data for order 42, and order 42 happens to exist across, or events for that order exist across all different partitions, then it's not going to work so well. So we want to make sure that our partitioning key is set correctly based on our business logic and the expectations of the application. But Kafka manages this consumer group and this consumption for us. So if we add in additional instances of the application, Kafka will rebalance and it'll say, okay, we've got up to 4 different partitions available for consumption. So you have up to 4 different consumers. If we lose one of those consumers, so the machine crashes or we decide actually just want to scale down, Kafka recognizes that. It says, okay, well, we've lost one of those consumers. I'm going to rebalance, and I'm going to make sure that that data is now being consumed by a different instance within that consumer group. So 4 partitions are still being read, but in this case, only into 3 instances within that consumer group. You can see from this that you have a limit on your parallelism based on the number of partitions. So if you decide we've got 4 consumers, so we go back a couple of slides and we see about 4 instances of that consumer, and we say, well, we're still not getting throughput we need to, we add in a 5th instance of the consumer, we don't get any greater throughput because there are only 4 partitions from which to read. That 5th instance of the consumer will sit there idle until it needs to take over. So we would increase our number of partitions and have like 8 or 16 or however many partitions we want to give us the parallelism that we need. You can repartition your data in a topic, but it's generally easier to get your partitioning right up front, because when you repartition, you've got like ordering to take into account. So the consumer API, it's a little bit more complex than the producer, because we have this notion of consumer groups, but it's still a very easy way to work with the data. You use it within your client application, bunch of different client libraries as before. It gets the messages off the topics into our application. It's horizontally scalable. We can add in and remove consumers from a consumer group as we need to scale and scale down. And again, there's a REST proxy as well. Now, we need to have a think about where our data is going to live. We've talked about conceptually where it lives. It conceptually lives on a log, which we conceptually carve up into topics, and there's an API for accessing those topics and getting data in and out. But where's it going to physically reside? How are we even going to run this thing called Kafka? This is where brokers come in, because brokers are actual JVM processes that run Kafka. So we run one or more Kafka brokers, each of which is a JVM process, and we would run them across machines. It's a distributed system. Now, you can run a single machine with a single broker, that's fine, but it works, but you wouldn't actually do that in production because it's a distributed system. It's designed to be distributed out. And this is, again, where the partitioning comes in. So you have partitions for parallelism when we're processing the data. We also have partitions for being able to distribute our data across the available brokers. So you would start with 3 brokers, but you may well have many more if you need to. And those brokers will hold one or more leader partitions. So broker 1 here is the leader partition for partition 1 and partition 4, and then the other 2 brokers have also got leader partitions. And in fairly standard distributed systems practice, we have our leader instances of our data, and then we also have replicas. So partition 1 is replicated across the other 2 brokers, partition 2, 3, and 4 also replicated across the other brokers. So this means that if we lose a broker, if like broker 3 goes bang, we still have the data for partition 3. So broker 3 was holding the leader partition for, broker 3 was holding the leader partition for partition 3, but we still have partition 3 on broker 1 and 2. So in this case, broker 2 will take over responsibility for serving partition 3 leader partition. So a distributed system, we have redundant copies of the data which is replicated by Kafka automatically across its different brokers. So this is pretty good. This gives us a very solid foundation for capturing events that are happening all around us, for consuming those events, for building applications on those events, for doing so at extremely high scale if we want to. We can start with a small little kind of 3 broker system. We can scale it like kind of as much as we want to handle the rates of data that we might be working with. We can capture events as kind of like orders and clicks. We can also work with events in terms of reference and lookup data like our customers. All of our data that happens around us, we can capture through Kafka and use to drive our applications through the producer and consumer APIs. But in a sense, we're just getting started. We're just laying the foundations for this platform on which we want to build applications. And it is very much the foundational approach. We've taken the concept of a distributed commit log. We've built some very powerful APIs around it for getting data in and data out and carving that data up into topics. But let's think about the kind of things that we actually do with that data once we've got it in, the kind of patterns that we often end up following. We do things like saying, let's build a pipeline. I said earlier, Kafka is not just for building pipelines, but we can build streaming pipelines with it, sure. We can say, let's take data from a database and go and stream it into S3 or go and stream it down to HDFS. So now we're looking at this picture and we're saying, well, I guess I need to write a producer API application to pull that database to get the data in, and a consumer API to read data from a topic, to write it to S3 and maybe a Spark job to go and put it to HDFS. Or we say, well, actually, I'd like to build an application against Kafka. And this application, it's going to be a microservice or a set of microservices that are going to replace functionality of an existing system that is built on top of a relational database. So we can't go and change that existing system. It's legacy. We daren't touch it for lots of reasons. But that database, everything that happens in that application is captured in that database. We can actually hook into that database. Why don't we pull that particular set of tables in the database, get the data out into Kafka, and from there we can build our application which responds to those events. So again, we say, well, that looks like a producer API to me. We're going to poll the database. We're going to write a bit of Java that's going to go to that database and poll it and find out what's changed and write it into a topic. So we say, well, this is great. We've got a couple of producer applications, a couple of consumer applications, but I can see a bit of a pattern forming because I've got data coming in, I've got data coming out. So maybe I need to build myself a framework which I can kind of say, well, this is going to integrate data from here, and then I need to serialize it, and then I need to be able to scale it, and then I need to be able to kind of handle restarts and make it pluggable and configurable and kind of like a nice generic framework. And this is great because I can actually set myself up a framework. I'm going to go away and write one. I'm going to write a spec for it and a one-pager. I'm going to go write a framework. This is brilliant. But as Admiral Akbar would tell us, it's a trap. Writing frameworks is a whole bunch of fun, but it's not actually delivering business value. Because being able to write data from Kafka to S3, being able to ingest data from a database into Kafka is not advancing your business beyond what everyone else is also doing. So as much fun as reinventing the wheel is, that wheel has already been invented, and it's called Kafka Connect. So Kafka Connect is part of Apache Kafka, and it lets you do integration between systems upstream into Kafka, from Kafka downstream to numerous other systems. And so you can actually build these end-to-end pipelines. You can say, I'm going to integrate with this system upstream with a message queue into Kafka to go and drive my application. I'm going to take data from this database upstream into Kafka to go and drive down to Snowflake or BigQuery or S3 or anywhere else I want to put that data. To use Kafka Connect, it's just configuration. We don't actually have to write any code. You should not be writing any code if the plugins exist already, because it's done for you. You say, I want to integrate with this system to get data into this topic. And we can still do processing on that data if you want to, using additional pieces. But the point is, the base part of that integration framework has been done for you. It's a pluggable architecture. It's extensible. There's a Java API if you need to go and write a different connector from what already exists. But in a lot of cases, that already does exist. So on Confluent Hub, you can go and find numerous different kind of vendor and community integrations that exist for Kafka Connect. And as I say, if you don't find one, you can go and write your own. But most of the time, they do. I talked very briefly, I think I probably spent one word on it in that previous talk about Kafka Connect. And I said serialization. And this is actually a really important thing, again, when it comes to building applications around Kafka beyond just the foundations that we have in its pub/sub capabilities. Because these key values that we're putting onto our topics, we're kind of like an event happened and we put it onto there, and then we read this message out and we do something with it. And so far, I've waved my hands and I said, oh, it's a key and it's a value. And that value could be a byte, it could be like a bunch of stuff. But what actually is it? Like, how do you actually build something that's going to write that data in a sensible way and be able to read that data and make sense of it? Because to Kafka, it's just bytes, which is very, very powerful, but it's a double-edged sword. It's powerful, but it also risks you doing something like this and saying, well, okay, I'm going to put a message onto Kafka and it looks like this. And we can eyeball it. And the poor soul who has to read that as the consumer and build an application against it or put it into a data warehouse to process says, well, I reckon that's got some tabs. Maybe it's tab separated. And I can see a couple of dates in there. So maybe it's like a timestamp and maybe an address. And like, who knows what it is? And we could like have like instinct, which kind of like spidey sense, like, I know all of the fields, but we're still guessing. What Kafka lets us do is build really nicely, loosely coupled systems. Data goes in, we can read that data, other people can read that data, and it's loosely coupled. But as soon as we throw away any concept of like, well, what are we actually exchanging here? Our APIs, our contracts between these things, and we go back to like, let's just chunk some data onto there, and then like, I'll drop you an email when I need to know what that is. Or can you send me a Slack message because I'm not sure what that is? And is this a space or a tab? Or like, is that a data or an integer? Like, you start hard coupling these things back together. The people reading the data have to phone up the people writing the data, and it's just like a bad idea. So think about how you're going to serialize your data. There's really good ways to serialize data. There's fairly poor ways to do it, and like a few in between. The key thing here is the schema for your data is really, really important. The schema acts as your API, as the contract between your services. Whether you're building microservices, whether you're building data pipelines, they're all kind of like conceptually services, and the schema acts as your contract. So you want to use something like, or you maybe don't want to, but you should use something like Avro, like Protobuf, like JSON schema. because it serializes onto your Kafka topic, and the schema is preserved, is stored in the schema registry. So the schema registry holds those schemas, it enforces those schemas, so you can't write data onto the topic which isn't compatible with a schema that you've declared. And now your consumers, instead of having to phone you up and say, like, what's this thing? Your consumers go to the schema registry, read the schema, they can deserialize it, and they can know what all the different fields and data types and so on are. So that's a really important thing. This is where the ecosystem part of it comes in. We've got PubSub fundamentals, foundations, but actually building things which aren't a pain to maintain and which aren't brittle and don't break when you blink. Building things like a schema around it actually let you build proper production-ready applications and analytics. Let's have another look at what we're doing with our consumers. We talked about the consumer API, about getting data out of Kafka, and we can have different consuming applications and consumer A and consumer B. One could be doing fraud processing, one could be doing fulfillment, one could be doing analytics. We can use the same data for doing lots of different things. But what are some of those things that we're actually doing? I talked about like fraud processing and all these different things, but let's actually have a think. What are the kind of things that we do with streams of data, with streams of events? We can say, well, okay, here's an example. We've got data coming from like a factory floor, and we've instrumented all of the different robots, and we got all of this payload from them all the time. We've got sensor IDs and temperature readings. What are we actually doing with it? And there's a finite set of things that you can do with data. You can say, I'd like to create an alert against it. I would like to sum it up. I would like to look for anomalies in that data. I would like to take that data and probably route it somewhere else. But a lot of things that we're doing with the data, we're actually talking about stream processing. We're saying, as things happen over time, we've got a stream of different events. It's immutable, it's append only, and it's unbounded. It's continually happening. It doesn't finish until like the world goes bang. So it's unbounded, it's happening continually, and we want to process these events as they come in. So let's imagine we've got widgets. So our factory floor is creating widgets, and we've got red widget information and yellow widget information. We've got an application, a business requirement to say, I want to process a stream of events only related to red widgets. So we could say, okay, I'll create a consumer API application, and I'll subscribe to this topic, and I'll read every single message, and I'll look at the particular field within it, and I'll look for this condition where color equals red, and then I'll do this with it, and I'll write an application around the consumer API. And you could do that, but it gets pretty low level pretty quickly. And particularly when you do things more than filtering, when you start doing aggregations and joins and stuff like that, you're writing all of it. It's kind of fairly low level. Whereas you could say, I know, I'll use the Kafka Streams API. And so again, this is part of Apache Kafka. So as well as the producer and consumer APIs, we talked about the Connect API for integration, we've got the Streams API for doing stream processing. It's part of Apache Kafka, and it's a Java library that you bring into your application. And you say, okay, I'm going to read from this particular stream, I'm going to filter for this particular condition, and I'm going to write it out to a new stream. So it gives you this API for doing it. So instead of writing consumer API applications, we write streams applications, and they're still just Java applications. So in the same way that you test them and you deploy them and all the rest of it, you do the same thing, but you're using the streams API within them. Now, you may not be using Java. So you may say, well, actually, I would rather use something like SQL. So KSQLDB gives you the same concepts that you have with Kafka Streams. And it says, okay, I'm going to declare what I would like to do, but this time, instead of using Java, I'm going to use SQL. And you can access KSQLDB from other client libraries. So you can use it from Python, from Go, from Ruby, or whatever, and you can access KSQLDB using this. So with KSQLDB, we do a similar thing. We say, create a new stream that's populated by a select from the inbound matching this particular predicate. And again, we do the same thing. And KSQLDB is actually built on top of Kafka Streams, which is built on top of Kafka itself. So Kafka Streams, KSQLDB, they're both distributed scalable systems also built on top of Kafka. So with KSQLDB, we can do things like this. We can say, I would like to create an alert if the weight of a widget is over this. So this will create and populate a new Kafka topic. So from that Kafka topic, it's just a Kafka topic. So any consuming application can subscribe to that. So we have a system somewhere which says, well, I generate alerts, just give me a feed. Will you subscribe to this topic that we're populating with this data? We can say, I'd like to create an aggregate. How many widgets have we created on each production line? Or what's the average temperature of a particular sensor? And if it's over a certain amount, then again, we're going to create an event onto a new topic, which is going to go and generate an alert. We can also use KSQLDB for accessing Kafka Connect's integration with other systems. We can say, take this stream of data and go and sit it into S3 or something like that, for example. So I want to show you a couple of these things very briefly. I mean, I could spend all day talking about this kind of stuff. I could spend all day demoing it. There's actually a ton of stuff online if you'd like to go and have a look at it. But let me show you fairly briefly, and then I'll wrap up with a few resource slides, and we'll do some questions as well. So the demo I would like to show you comes from the demo scene repository on the Confluence GitHub. So you go along to this, you can find all the different demos here. And this is the one that I'm showing you today. It looks like this. So it's just goes through, it's a cheat sheet, so you can access it yourself. It's Docker Compose up, and then you've got the environment to go and provision and work around with. So that's exactly what I'm doing here. And it looks like this. So to start off with, we're going to do this. We're simply going to say, let's have a look at the data as it's flowing into a topic. So I'm using an excellent little tool called Kafka Cat here. So if you're used to Kafka already and you don't know Kafka Cat, go and check it out because it's brilliant. It lets you, it's kind of like Netcat for Kafka is how it describes itself. You can use it for producing, for consuming. So here we're saying we're going to take data from this particular topic on this broker here, and we're going to consume that data. And the data on that topic is, if I pause that, it's a bunch of buy and sell. It's just like stock trade data. So that data is flowing into this topic all the time. Just run that again and check my terminal's working. Terminal's not working. Let's create ourselves a new one. That looks better. Okay, so data is flowing into the topic all the time, continually. And we want to do something with that data. We want to say, I want to take the data for a particular symbol. I want to create an aggregate for it. Now we could take this data, we could go and stream it into a database and create aggregates in the database, but we don't always want that raw data, for example, in the database. Sometimes you just want to pre-compute aggregates. Sometimes you do, and that's fine. And the whole point of Kafka is that you have that raw data. You could choose to put it there. You could choose to put it somewhere else. You could choose to pre-aggregate it, but you have that choice. As soon as you decide to say, I've got this raw stream of data coming in from wherever, I'm going to write it onto this database as an aggregate, you lose that raw data. Or I'm going to go and write it somewhere else, and I'm going to apply this transformation to it. You're now coupling your systems together. Whereas we have the data in Kafka, and we can stream it over here, we can aggregate it and stream it over there, we can consume from it directly. You have that freedom to build your applications in a much more loosely coupled way without introducing additional dependencies between them. Anyway, I digress. So let's have a look at how we could take this data and aggregate it. So let's clear that screen there. And we're going to say, let's launch into KSQLDB. So KSQLDB, it's got a command line interface. There's also a web interface as well, if you'd like to. So that's hopefully going to start up. That's started. And if I say show topics, it says, here are the topics that you've got on your particular Kafka broker at the moment. So we've got a topic called trades. I'm going to say create a stream against this topic. So it's going to say, I'm going to take that topic, I'm going to get the schema from the schema registry, because we can see it's been serialized as Avro, so the schema is available to us. So we create a stream, and a stream is a KSQLDB object, and I can say show streams. It says you created a stream called trades that reads data from this Kafka topic called trades. I can say describe trades. It says, well, here is your schema, because you had declared that schema already when you serialized the data. Now, KSQLDB, it can work with JSON data, it can even work with CSV data or TSV data, but it also works with protobuf, with Avro, with JSON schema as well. And we can read from this data. So we can say select from this particular inbound stream of data, and we can apply predicates. Because we've applied a schema, we can now identify particular fields within it. So I could even say this. I could say select the side and the symbol and the quantity from here where the symbol equals this. Now, as that data arrives, so we're now going to the end of the topic, which is why we're not getting screenfuls of information. It's just gone to the end of the topic, the latest offset. So as new messages arrive, they're showing on the screen here. And we can take a select statement and we can write it out to a new topic. So we can say, let's take this, and we're going to say create stream new as. And actually go and build a new Kafka topic. So if I say show topics, we've got a topic called new, and I can actually just run a consumer against that, print new, and that now shows that Kafka topic as it's being populated. So as a new message arrives on the source one, we pick out the particular fields based on that predicate, and it writes it to the new topic. But anyway, I said I was going to build you an aggregate, didn't I? So let's build an aggregate. So we're going to take this data, and we're going to do this. I'm going to say set the offset to the earliest. I would like to build an aggregate based on all of the data that we've got in the topic, and then go and create a table within KSQLDB. It's going to build these aggregates from our stream that we declared using a tumbling window. So it's going to slice it up into 15 minutes, and it's just for that particular symbol that we asked for. And what I can do here is I can actually say, show me the data that exists in that table. And it says, okay, here is the data in that table. You'll notice I'm using something called a table here, and it's actually just given me the output. And what KSQLDB has done here is it's basically a materialized view. I can query that materialized view directly. It's storing this state, it's materializing this state within KSQLDB. I could query that state directly from an external application using a client library or the REST API if I wanted to. But that's kind of like by the by. Because what we're going to do with that data is we're going to say, let's take that aggregate that we're building. If I refresh that, you can see this one down here, this trade count for the current window, 8:45 GMT, that's going up. As we get new trades arriving in the source topic, they get added into this one here. So you can see that going up. I'm going to take that data and we're going to route it over into Postgres. In our example, we're going to use Postgres as our data warehouse, and that's streaming that pre-computed aggregate over into Postgres. So if we're going to have a look in Postgres and split the screen and do this, here's Postgres here. They select from this table. It says, well, here is your table. And you can see here, 8:45 at the top. You can see those values are going to go up because you're getting new data arriving all the time. So that was a whistle-stop tour, I realized it was whistle-stop, of the kind of things you can do with data in Kafka. It's not just about getting data in and then out. You can do stream processing, you can filter it, you can aggregate it, you could join it. If I'd brought in an additional table made from a database or somewhere else, we could have said, well, this symbol here relates to this particular company and all this other kind of stuff, and join that into those events as they arrive. There's a whole bunch of stuff you can do. So that's the kind of things you can do with it. But just to wrap up, we started at the beginning talking about events. Events being these unbounded series of things which happen in the world. They're just things. They model our businesses. They model the interactions that go on in the world. They can be human generated. They can be machine generated. Like there's something that happened. That's all. We said, okay, we're going to store it as key value bytes, and we're going to store it in this immutable append-only distributed commit log. So as stuff happens, we write it to this. We're going to carve it up into topics, like different entities within those topics. I'm going to have produce from consumer APIs to get the data in and out. But we said, well, that's not really enough. That's like the foundations, that's the starting point for it. But we need to integrate with other systems. We need to do stream processing. And so this is what Apache Kafka gives us. Produce from consumer APIs, the Kafka Connect API, this Kafka Streams API. And around that, we have other components in the ecosystem. We have the schema registry, we have KSQLDB, we have numerous other pieces also. If you want to try it out, you can go and download Confluent Platform. You can also go and try Confluent Cloud. So there's a bunch of codes and stuff like that on the screen here that you can use to get money off your bill each month when you're using Confluent Cloud. So you just go and spin up a cluster, and the great thing is it manages it for you. So you've got managed Apache Kafka, you have KSQLDB, you have Kafka Connect also. To go and learn more about Apache Kafka and Confluent Platform, check out developer.confluent.io. There's podcasts, there's tutorials, there's videos, there's blogs, there's a whole bunch of stuff there. So finally, thank you very much for your time. I hope it's been useful. Follow me on Twitter. Tell me if you liked it. Tell me if you didn't. It's always good getting feedback. You can see more of my talks at that link below there in the middle. I've also got some videos on YouTube as well if you want to go and check those out. So thank you very much for your time. I'll head over to Slido now and see if we've got any questions to discuss. Okay, so let's have a look here. Can partitions reside on different machines? Yes, partitions definitely can reside on different machines. That's the point of brokers and it being a distributed system, is that you'll have partitions spread out across those, both for capacity and for redundancy. So if you lose a particular machine, the partition will exist on a different one, and that machine can take over. and you can define a replication factor for different topics. So you can say, this topic here, I want like 7 different copies of it spread out, and obviously you need 7 brokers or more to do that, but yes, they exist across different ones. Is using Kafka as persistent storage with infinite retention a popular use case or an anti-pattern? Please clarify why. So I mentioned earlier, when data is read from Kafka, it's not deleted. Okay, Kafka stores that data from as long as you would like, and you can define that per topic. You can say, keep the data in the clicks topic for like 10 years, keep the data in this topic forever, or keep data in this topic for like 10 gigabytes worth, or something like that. And people do that. It's completely valid. The New York Times have got all of their articles, all of their content on a Kafka topic, going back to like 18 whatever or something like that. So it's completely valid. It's not an anti-pattern. Confluent Cloud has got stuff like tiered storage. So you're actually in the background for you automatically, like the cold stuff gets offloaded and it kind of does that very kind of clever stuff. So it's completely valid. It is not an anti-pattern to use it as your persistent store, because it gives you this system of record from which you can rehydrate other systems, from which you can process all of your data and reprocess your data. I'll do one more question. There's a question about Kafka by messages. The Confluent Slack group is a great place to come for more questions. To answer that one, I don't actually know the answer to that one. Does the offset of consumer groups can be set to a specific time? Yes. So when you set up a consumer, you can say, I would like to start at the beginning or the end, or a particular offset. And that offset can be based on a kind of an index of like 42 or a particular timestamp. So your consuming application can say where I would like to get that data from. I'm out of time. I'd love to discuss this more. If I didn't answer your question properly, ping me on Twitter @armoff, send me an email. You'll find my email address lying around, and I'm happy to discuss more with you. Thank you.